Hi, this is Sam, and I'm doing task number 3, pennies to heaven. I'm going to show the solution how to do it. First, they gave you an information that a penny is about 1/16 of an inch thick. And the first question, in 2011, there were approximately 5 billion pennies made. If all of these pennies were placed in a single stack, how many miles high would the stack be? So they gave you two information. Is that one penny is 1/16 inch of an inch high and 5 billion pennies, which is 5 and 9 zeros pennies. So in the year 2011, it doesn't relevant. It means nothing to the question. The question is how many miles high would that stack be? This is the measurement of time, and this is the measurement of the higher distance. So it doesn't relevant. We will ignore it. So first we have to the question said how many miles high. So we have sooner or later we have to convert inches to miles, and the conversion of inches to miles is 1 mile equal 36630 inches, 36,630 inches. So the next step is we have to change 1/16 inches into decimals, which is 0.0625, and yes, next we will change all values to proper scientific notation, which is using often multiply 10 to the power of n by and the n is the exponent, and it depends, and the high or low it is, the bigger or lower it is, depends on the position of the decimal, and the number here must be equal or larger than 1, but must be smaller than 10. So this is 0.0625, this is smaller than 1. So we have to change it by moving the decimal point. So if we're moving to the right, we must minus the exponent. Let's do the exponent. So here we move right 2 times, which means -2, and here the number is larger or equal than 1, but smaller than 10. And this is called proper scientific notation, and this is written in proper scientific notation. Same goes with this. Decimal point is over here. We have to move over 1, 2, 3, 4, 5, 6, 7, 8, 9 digits, and to the left, which means we have to plus the exponents 9. Same goes with this, to the left, which means we have to plus the exponent. One, 2, 3, 4. So the next step is we will convert the inch to mile by taking this and divide by this. So this is how it looks like. So this is how you should write when we divide it. And we can simplify it easier by we can simplify by these two by, and one way is called the quotient rule. Is we don't need to care about the base keeps the same always, but the thing is the exponent. We bring the exponent of the denominator up and switch the sign, and we take the exponent of the upper minus, like -4, which is -2 -4 is -6. We don't need it. And 6.25 divide 3.663 is equal 6.25 is 1.706 2517 06. So that is miles of 1 penny. So we have found so we have converted we have found the height of a penny in miles. So now we just need to multiply with 5 billion pennies. This 5 multiplied 10 to the power of 9. So it will be like 1.70625 6. Multiply 10 to the power 9. So we can simplify this using the rule called the product rule, which means also using the base and even the exponent. If we have the same base, we can add the exponent together. -6 -6 plus 9 is 3, and for this, and we just multiply, and we take this and multiply by 5 like normal. But 8.5. That is miles. The 5 billion pennies. The height of 5 billion pennies is this high. So the question A is done, and we move on to question B. In the past 100 years, nearly 500 billion pennies have been made. If all of these pennies was placed in a single stack, how many miles high would that stack be? We can just repeat the same process I've just done, but instead of multiply by 5 billion pennies, 5 multiply 10 to the power 9, you multiply 500 billion, which is 5 multiply 10 to the power 11. They have give one more information. Is 500 billion pennies is equal to 500 pennies, and we change it into proper standard form. Is we move to the left, which means add the exponents of base 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pennies. So like I said, you can just repeat the process of a penny and multiply it, but instead of multiply by 5 billion pennies, you multiply it by 500 billion pennies. Or maybe you can do a simpler way, like before you found 5 billion pennies. Now all you need to do is find 500 billion pennies. There's one way to do this a bit quicker, is using the answer of the previous question. By we see how many times this amount greater than this, which means how many of 5 billion pennies fit inside 500 billion pennies. Not how many pennies in 500 billion pennies, but 5 billion pennies in 500 billion pennies. How many stack of 5 billion pennies in a huge stack of 500 billion pennies. So here we have, by doing that, we take this and divide by this, which is, no, I'm sorry, this is the height of the mouse. 5 multiplied 10 to the power 9 pennies. How many how many times this fit in? So we take 5 multiply 10 to the power 11 divide 5 multiply 10 to the power 9. So like I said, so we take this, put up here and change the sign. 11 minus 9 is equal to 5 divided by 5 is 1, which is 1 multiply 10 to the power 2 times greater, which means 1 multiply 10 to the power 2, which is also equal 100, which means 100 of stacks of 5 billion pennies can fit into 500 billion pennies. So now, because it's 100 times great, because this is 100 times greater, which means the height is also 100 times, or 1 multiply 10 to the power 2 times greater. So you just need to take this and multiply by this, and you will find out the answer. So taking this, equal 10. We, like the product rule, we take the exponent here plus this exponent is 5 multiply, and we take this multiply by this is 8.31258531, and that is the height of 500 billion pennies. You need to find miles. So next, move on to next question. And also the 100 years, it's the same like question A. It's the measurement of time. It doesn't involve anything about the measurement of height, distance of height. The next question, C. The distance from the moon to the earth is about 239,000 miles. How many pennies? How many single pennies? One penny would need to be in a stack in order to reach the moon. So we have another information is 239,000 miles. Hello again. I'm sorry for cut for cut the video because there's time limit in there. I didn't see that until I saw the video was cut. So hello again. I will continue showing the solution for the question C. So I'll continue where I left off. So like they gave us the information is the distance from moon to earth is 239,000. I'll put this way. I don't need it yet. 239,000 miles. And yes, the height of a penny is this much. So what will and how many pennies? Each one penny, not a stack of 5 billion pennies or 500 billion pennies. Just one pennies. How many of one pennies would need to be in a stack in order to reach the moon? So this is how much. First thing is you have to change it to proper scientific form. Is hit point, and we move over to the left, which is add the exponent to the base 10. So move 1, 2, 3, 4, 5. And also the number have to be between more than or equal to 1 but less than 10. So yes. And finally, all we have to do is be taking this and divide by this. 2.39 multiplied 10 to the power 5 divide 1.706 251,706 10 to the power -6. And yes, we keep the base of the 10 the same, and we bring the -6 up, and we'll change the sign to +6. 5 plus 6 is equal 11. And 2.39 divided by this is equal 1.4. So there you have it. This is how much pennies. How much for one? How long? How high is the one penny? And this is how much pennies required to fit the distance from the moon to the earth. So that's done. So we're done for question C. And finally we move on to the challenge D. How many times would you need to fold a piece of paper in order for it to reach the moon? Information. One piece of paper is around 0.01 centimeter thick, and the distance to moon is 384,000 kilometers away. So we have two information. It's 384,000 kilometers away and 0.01 centimeter. This has nothing to do with a penny. So we don't need to care about it anymore. About new units and new values. First is 0.01 centimeter. A piece of paper. 0.01 centimeter. And distance from the moon to the earth is 384,000 kilometers away. So first we have to change all the values to proper scientific form. So to change this from here, multiply from here, you must make this number between equal to 1 or more than 1, but must less than 10. So we have to move the decimal point to the right 2 times, which is into the -2 minus exponent. And for this, the decimal point is over here. We move it to the left. 1, 2, 3, 4, 5. Which means add 5 to the exponents. So next we will, and also we have one more data is the conversion. 1 kilometer equal 100,000 centimeter, which if we change to proper scientific form, it will be 1, 2, 3, 4, 5 multiply 10 to the power 5, because if move to the left at the exponent, each time we move the point, the decimal point. So finally we will convert the centimeter to kilometer by taking this, divide by this. We like the previous, we keep the base the same. We bring this up and change the sign. Is -5. Keep the base the same. -2 and -5 is -7. 1 is the same. 1 divided by 1 is 1. So this is the answer. 1 multiply 10 to the power -7 kilometer. And now we'll need this in distance from the moon. Now the equation for doing this, some of you might think that I just need to take this and divide by this and we'll find how many pieces of paper. But the question is that how many folds, not how many pieces of paper placing on top. So here is the equation for you to solve this. Is 1 multiply 10 to the power -7 multiply 2 to the power n equal 3.84 multiply 10 to the power 5. And also let n be the number of folds. Let n be the number of folds, and y n is the number of folds. It's the exponents, but not the number itself. Well, because here it is. Example, this is a piece of paper. So if I take this and fold it once, which mean this is, we're talking about the size, not the area of the surface. So don't worry about that. We'll worry about the height of it. So if we fold, we have 2 layers, and it's double of the initial one. It's double than the one of them. This is the first fold. And now if we fold for the second time, it will not be like this, but it will be like this. Because if you fold, you're taking the 2 folds and you're taking the 2 layers and put it among the other 2 layers, and which means like 2 by 2 layers each, which makes it 4 layers. So the height is 4 times the height just after 2 folds. The first fold is 2 times height, but the second fold is 4 times height. So it's and after the third fold, it will double the whole everything. It will become 8 times fold. So like this, like let's take F and put example. If I replace n equal 1, which is 1 fold after 1 fold, 2 to the power 1 is 2, and this multiplied by 2 is equal something, but you know that it definitely will be twice higher than this because it's multiplied by 2. And if this multiplied by 2 and 2 to the power n, if n is 2 to the power 2 is equal 4, which means it will be 4 times higher, just like the example I just showed you, which is true and it's relevant. It fits with the problems. Like every time you fold, it doubles of the doubles. It doubles of the doubles. It's 2 multiply 2 itself, and if you multiply and you fold it again, it multiplies itself. So 2 multiply 2 is 4, and multiply 2 again is 8. So 8. So I mean it's double of the previous, but double of the previous, and the previous is the double of the initial, and keeps doubling. It's not like it's not like twice or 3 times, then 4 times, or then 5 times. It's double and double of the double. So this is the equation of how you should do it. And also the symbol is multiply 2. This is 3 folds. 2 multiply 2 to the power 3, and you guess it. It is 8. It is 8, which is 8 times double of the previous. Is only 4 after 2 folds. After 2 folds, it's 4. This Fn F2 equal F3 F1 equal 2 to the power 1 is 2, 4, and 8. Is 4 times. So there you see it. This is double of this, but this is also double of this. So this is 4 times of this after just 3 folds. So this is the equation to find out the solution to you. All you need to find, if you want to find the number of folds, all you need to do is find n. So to solve 2 to the power n, you first have to isolate it. 2 to the power n equal, you bring this whole thing to this side and also change the sign, which is divide. 3.84 multiply 10 to the power 5 divide. So hi again, it's me. Seems like me. The last video had hit the 15 minutes marks. So I'm gonna make a third video and it's going to be a short one. And we'll continue what I just left off. So for the formula, so to continue the equation of number of folds, so you reach. So this part is where 2 to the power n equals 3.84 multiply 10 to the power 5, and we move this to over here and change the sign is in change the dividing is divide 1 multiply 10 to the power -7 to the -7 and 3.84 by 10 to the power 5 1 multiply 10 to the power -7, and we move the -7 up and change the sign is +7 equal 12, and 3.84 divided by 1 is 3.84. And to be honestly, when I get here, I don't know how to continue. So there is another way to complete this is by using the calculator. So first, this is how it looks like on the calculator screen. So first is so this is how you should type in the calculator screen, and you click equal and you see that the answer. It's unnecessary. If you don't put the brackets in, it's okay, but it could be confusing a little. It could be confusing a little bit, and you will have the answer over here. Then you keep and you click multiple, then 2, which is how it looks like. This is how it looks like. Answer over 2, and you keep repeat many times until reach 3.84 multiply 10 to the power 5, which is the distance from the moon to the earth. Distance from the moon to the earth. And my answer is the number of folds n equal 41 to 42 folds. Number of folds is 41 to 42, and because the exact number is between 41 and 42 is like 41.5 decimal, but for folds it's impossible. There's to be like 41.5. There's only 41 or 42. There's no 41.65 or something. 41. If I plug this into the calculator for n, I'll get the number that's smaller than the required. But if I put 42 in, I'll get more than that. So the answer is between 41 and 42 volts. And finally, we have finished the challenge. Question D.